All right, we are rolling now with the CephFS mini.
Real loud.
All right.
Hey, Josh, can you unmute?
Yeah. All right, so the CephFS starter tasks. You want to kick that around a bit, Greg?
All right. So for this, I just wanted to go through a bunch of. Sorry. Okay. So there's a bunch of tasks in the CephFS tracker, and it's difficult for anyone who's coming in and wants to get started on stuff to have any idea which ones are sort of feasible for them. So I went through our backlog and just picked out a bunch of the ones that it looked like could be done by someone who didn't have a lot of experience in the CephFS code base, and that I thought we knew how to do. And so there's not really any theme to this other than that. And I thought I'd just run through them here. Let's see. So if you look at the blueprint, it's just like 12 tickets or something. The first three all pretty much go together and are about our cache dumping. And this is a command in the MDS that lets you just tell it to dump out the state of the entire cache that it has in memory, and that can either come out over standard out or to a file on disk. And right now, it's very coarse. You can tell it to dump the cache, and it dumps everything that we have. But then if you want to do something specific with it, you need to go through and pull out all the information you're interested in. So we have a ticket to dump the cache for that a particular client is involved with, or that an inode, or that is one particular inode, or that lives underneath some specific path. And this isn't too complicated if you are interested in doing it. There is a single function called dump cache in the MD cache class, and right now it just runs through everything. And if you're interested in implementing any of these tickets, you just go into that function and add a couple of parameters to it based on, or maybe you'd clone it or something, but you'd basically take in through the admin socket the state you're interested in, and then just go through the dump cache function and filter in the loops based on these things.
I guess for filtering by path, you probably want to do a lookup by path and then recurs under that, rather than sort of applying the filter on every inode.
Yeah, that might make more sense. And for the client one, there's a comment on the ticket that says you should follow the inodes referenced by session caps, which is a specific state or a specific piece of information that's referenced. So that's not too hard to do if you just look at it. So anyway, those ones are pretty light. Shouldn't be too difficult. Next one here that I have is that
2 draw 3 or 4 copy.
All right, and I actually wanted to check with you about this one, John, because I don't remember how much of this got done with all the other stuff you've been bulldozing in. Is number 7325, which is a tool to examine directory fragment objects. So there's a bunch of tooling around that now, right, John? In like the reverse repair stuff, but we still don't have one that just will go and list them. Is that right?
Yeah, that's right. Yeah, all the code exists for touching them, obviously, but it's not wrapped up in an actual, ls command.
Right.
That will probably be a natural thing to do when we add the template scrub of the metadata objects, because we're going to need something that knows how to walk the fragments in a directory. Although I suppose if this tool was limited to just listing an individual dir frag and didn't have to know about frag trees, then it's it's pretty trivial, really.
Yeah. So if you're interested in this one, you should come talk to us. But basically what this is going to have to do is go read an object off disk, and I don't remember how many helper functions we have for all of this, but to go read an object out of Rados and then just parse it. And there's parsing code in various places. You'd probably have to make some of it a little neater. Let's see. The next one on my list, these are sort of organized in the category of stuff they work with, and then I tried to do them from easiest to hardest. Is one that John created, which was that to try and create an MDS specific assert, the dumps cache state is the number 11174. So throughout the Ceph project, we have an assert that we call that just checks various states, that lets us check that some condition is true, and then if it's not, then it crashes the daemon. And that's useful and all, but a lot of times, we want to dump some, or a lot of times it's saying that some complicated thing is false, or at least that something, if it's false, is the result of a complicated set of situations. So it would be really good to get more detail about what's going on in the system when these asserts fail. And we make some attempt to do that by, for instance, if you have an assert failure, then the generic stuff will dump out the in-memory buffer of log messages from our dout logging. And that can be more detailed than is normally dumped because we collect more messages in memory than we actually write out to disk in normal circumstances. But if we assert out, then we do dump them. But John's listed here a dump of the MD cache, a dump of the ops in flight, and then options to add information to the central monitor log, or to tell them MDS monitor that we're dying, so that we don't have to wait through the timeout while the monitors detect that we're dead before the failover happens, or just the system gets marked laggy. And so much of this you'd have to write from whole cloth, but, well, not from whole cloth. So as I mentioned, we have a function called mdcache, or a function to dump the mdcache cache. So you would have to call that. There's a dump ops in flight command in the op tracker that you have to call. You'd have to figure out how to send the messages, but we have helpers for all that. Sort of the part of this that would be difficult, I think, is learning about the infrastructure involved in how the generic asserts work in Ceph, and then going through and figuring out a way to do these things while blocking other progress, which suddenly makes me think that maybe this one's harder than I'd thought. But
so I think pretty much everywhere that we would actually want to call this, you'd already be holding the MDS lock, because it's things like when you see inconsistent things in the MD cache, and you're always holding the lock if you're looking at that.
Yeah. Can we send and receive messages while we're holding it, though?
Yeah, you can send. You can't receive, because you'll be in the middle of a dispatch loop, so you can't guarantee you're not blocking someone from seeing that message. But it's the sending of the message to the mon is basically the same path as already happens when you call damaged. The beacon.send and wait, or whatever it's called, and that pretty much, that works well enough while you're holding the MDS lock. It may well be that it's not guaranteed for you to see the response to that, but yeah.
Okay. And then this last one that I had in the MDS, I'm actually not sure how difficult it would be, but I think it would be interesting for someone who wanted to get in deep, which is to support cache eviction. And this is, so the MD cache has its in-memory cache, but it's really difficult to tell if something has been removed from that cache or not, which can be a useful thing to want to check when you're running white box tests of the CephFS system. So I don't think this would work, or this wouldn't work if clients had the file open or something. But if clients weren't actually using the file but just had, extra caps on it because they like to keep caps around, or if clients had it in use, then we ought to be able to just dump inodes out of the cache and flush them to disk if that's necessary or whatever. And I'd like a command via the admin socket for debugging purposes to do that. And so this one would need to revoke all the capabilities on that D-entry or inode that any clients hold. And that's the part that I'm worried about, because I know that we have a lot of helpers around it, but I'm not sure how hard that would be. So this would be a good one if you want to start working full time on CephFS or something, but and you would get a tour of a lot of the more difficult pieces of the code, but not have to go in and muck around with them too much. Just you would have to go see them and make some very small specific changes. But this would involve setting up a command in the admin socket and then adding functions that go in and do the capability revokes, which which we can find you models for. And then once no one has any capabilities on them, flushing the cache or flushing the inodes out and evicting them from the cache.
So Greg,
okay.
Is this something like the F advice in the kernel side?
I mean, so there are F advice commands to not keep stuff in cache, but no, this would be a debugging tool, or not a debugging tool, but a QA tool. So we would write in our Toothology suite, we would write a test that does specific things with inodes, and then kicks them out of cache, and then does something else to make sure that the state of the inode, or that the inode is in the right state, and that we don't have some bug in how we're doing write out and then reading off of Rados that's being masked by it just staying in memory all the time or something.
Okay, so this sounds like a command line tool, right?
Yeah. So the daemon, all the daemons have something called have their admin socket that you can issue sort of debugging and commands to.
Okay.
The most common uses right now are for dumping. There's an op tracker in the MDS and the OSD now, which every time there's a message from some other daemon or from a client or whatever, then it creates an op and you can track these. And so there's a command dump ops in flight that shows you everything that's happening on the system right now. That's, I think, the most common one that people use the admin socket for. And we use that occasionally for in our Toothology tests, I think. But then there are more exotic ones like let's see, help me out, John. Which ones are actually in the admin socket? Because they all should be, but I know we just moved a bunch of them in there, and I'm not sure if everything is. So I think we have commands for migrating subtrees between metadata servers, which is something you shouldn't really do except when you're trying to set up a specific scenario.
Yeah, we have, there's migrate directory, and also I just re-added the split and merge for directory fragmentation.
Right.
There's still a couple of old legacy MDS-TEL ones that haven't been reinstated yet, but yeah, I mean, they're entirely not something an end user would necessarily want to do. Actually, maybe we should start prefacing these things with debug or something like that.
Yeah, or requiring that you start up the daemon in a debug mode or something to make use of them. Anyway, yeah. So those are sort of options for twiddling the internal state of the MDS without that you wouldn't want to do just because it's running in a cluster somewhere. You do it because you have a specific goal involved with trying to test a specific feature. And this would be one of those. Okay, so moving on to the client-side stuff. Ticket number 4734 is to implement async interfaces for libCephFS. And I guess the motivation for this is that Samba has some async interfaces that are supposed to be much faster. So it'd be cool if we could hook up to those. And I don't think there's anything too complicated here. It would be sort of an API thing. You would go into libCephFS and see how it calls into our client stuff, and wire up some async rather than synchronous ones.
Isn't a lot of the client stuff itself blocking though?
Honestly, I don't remember how much of it is. I should have looked at this last night. I managed to go through most of the other tickets, but not this one.
A lot of the client calls are kind of from the single-threaded fuse world. Yeah, there might be kind of more work than that.
You would need to go down into our actual client.cc files as well to deal with this. If you do, it's not hard. Like I'm looking at the LL read function, which I think is what I actually don't remember which variant that libCephFS uses, but like our LL read function is blocking, but sort of the blocking stuff is internally async, so it's not hard. So it wouldn't be hard to like expose that from just one level down. Yeah. There. And it all sort of happens in that one level. Around the call to make request, I think is exposed in all these. Anyway, so that would get you into the client side and sort of give you a tour of the important interfaces involved there. Next one is the user space client has, along with most of the other Ceph processes, has something called perf counters, performance counter. That's short for performance counters, which you can access through the admin socket and to get their states, and they're just counters of averages or sums or current values or whatever. That's ticket number 4355. Now there is already a perf counters in the client, but it has only has three values, and they're not terribly useful. Their average latency of replies to the MDS, of processing a request from the kernel, and of doing a write operation to a file. The big one that I think that we should have is the number of requests which are outstanding to the MDS. But anybody who is interested in getting to know the client side code, just browsing through that code and looking for important data structures would see all kinds of things that could be useful to put in a structure like that. So I started going through it last night and was like, okay, so the size of the cache of the inodes that we have internally, the size, let's see, not anything that the object cache would have, but so yeah, like our internal cache size would be another obvious one. And really just what you'd want to do if you were interested in this was sort of read through not all of the code, but sort of like start with the data structures in the client source tree and in client.h, and look for and then sort of go through the important operations and look for things that you think might be interesting, and then just wire them up to the perf counters interface. So nothing too tricky, just sort of sit down and do it, and then send in a pull request. And then finally in the client, then right now in the user space client, if you try and mount and there isn't an MDS cluster running, then CephFS just hangs on the command line when you invoke it, and there's no indication of what's going wrong, and why it's not proceeding to mount. And every so often we actually get someone who on the mailing lists who, ran through the Ceph quick start and didn't set up an MDS cluster and tries to mount with CephFS and doesn't know why that's not working. And so to resolve this, I think it's not super elegant, but I think the way to do this is just to, in CephFS, when the startup happens after the Mon client is established, I think you just want to issue probably one of the admin queries via the Mon client and make sure that there's an MDS running, although there are several different ways you could do it if this is something you're interested in. And if there's not, then error out before we do the fork. Or maybe this is after the fork, but error out and shut down the processes rather than just sitting there and waiting and polling, which is what it does right now in one of the interior functions.
So we probably want this behavior to be disableable, because if somebody had an orchestration system that went out there and configured their file system and configured their clients at the same time, in some cases it would be kind of legitimate behavior that you'd want the client to come up and wait for the MDS cluster to be configured.
Yeah. And then if you're really brave or just prefer working in kernel space to user space for some reason, there's an equivalent ticket to this in the kernel client, which actually does not hang. It issues an EIO error, I think. I forget which one it is. Just a minute. Which was actually the original ticket that inspired this one. But I was trying to stay in user space for this talk. Okay. So here's one that involves both the server, or both the MDS and the client, which is to have a client opportunistically update backtraces on files. So every file in CephFS, we write a backtrace, which is just like the path of where the file is, along with versions for each entry along that path. We rewrite that backtrace to the first Rados object in that file, and we use this for recovery purposes in FS check and for repair tools. Now, right now, the MDS is responsible for writing this out, which works fine, and the MDS needs to be able to write it out in case you have an old client connecting. But it does mean that in a lot of common use cases, some of which people have complained to us about, when it's like something like rsync, then if you're rsync a bunch of small files, then you have two writes to disk for every file, one when the client writes out the file to disk, and then one when the MDS writes the backtrace to that first object. And that's sort of annoying. And since the client already tends to access the first object whenever it creates a new file, it would be convenient if the client was writing that backtrace out for us. So I think the way to do this, without making everything super complicated, is just to have the client do the write out only once on the initial file create, and to do that by putting a new buffer list in the mclient reply messages inode stat structure, which is just a buffer list that the client doesn't interpret at all, and which the MDS would prepare with the backtrace data that it wants. And then new clients can decode that, when they decode the inode stat, we'll see this extra buffer list. And if it's an old client, then it'll just skip the buffer list because it'll be an optional bit of the data. And then the client will need to keep track of that buffer list, and whenever it sends a write out to that Rados object to append an a setxadder command to the right with this buffer list and to the backtrace xadder. I don't remember what the value is, but we can look it up. And remembering that state, I think, should just be in the client's inode structure, just like make it a member and mark it with a Boolean to write or something, and then check whenever performing a write whether we have that flag set. And if we do, then append it to the right. And then the client, and we would need to extend, I think, the cap write back structure and message that the client uses to the MDS. Extend that to have a wrote backtrace flag of some description. And then in the MDS, whenever it sees that flag on a response to whenever it sees that flag on a particular inode, then it can call the cinode clear dirty parent function. And then it just won't try and write out the backtrace. So I'm not quite sure what the best way to set up that flag is. I think the simple one is just to add a Boolean somewhere. We could try and use something more complicated by making it a piece of the full capability system. And I'm not sure if that would have any real advantages for us. Like in the future, we could try and get the client to write out extra backtraces for us, not just the most recent, like not just on creates. And I think that might be easier with a full capability, but I'm not really sure.
So,
say something, John?
Just with that mechanism generally, you only get the client writing out the backtrace if it or rather, you only save yourself from having to write the backtrace from the MDS if the client writes back its caps indicating that it's written the backtrace before your create falls off the end of the journal and has to get written out. So I wonder if we could do it differently so that the client always did it, but that would require us to have a recovery stage in the MDS so that if the client died, we went in and wrote its backtrace for it.
Yeah. So I don't know. I mostly just assume that generally speaking, the create isn't going to fall off that quickly compared to the client's accesses. That might be a false assumption. In particular, do we actually need the create to fall off, or I think we just need to keep the inode? It's not when the create falls off, but as long as the inode is in cache, right? Create disappears. Because I think it just goes on the dirty parent list, and as long as the inode is still in cache or still being used, then it's going to keep getting moved forward to a new log segment.
I'm not sure. You may well be right.
So I think that it should keep getting pushed forward as long as the client is still using the file, but I could have that assessment wrong. Okay, and we have 2 minutes left. Okay, so I guess we'll run through these pretty quickly. Number 3244 is that, so we have some an FSAL, file system abstraction layer for the NFS Ganesha daemon project, which binds into libCephFS. But we don't test them at all, unlike our Samba bindings or anything else. So, and I got a report recently that they were a little bit broken. So it'd be great if we could test them in Toothology. So this one would be more about doing the work to set up Toothology tests that would install Ganesha, and also to do that, then we need to you might need to get help from us and lab access to set up a Ganesha Git builder, although I'm not sure about that. But it'd be great if someone could write some Toothology tasks that install and test Ganesha, and you could for the test you could look at what we do with Samba and our regular NFS tests and stuff. But configuring Ganesha to use CephFS and running those tests through. And then we've had a long-standing one, which is not really so there's a big file called MDS types, which combines a bunch of structures used internally inside of the MDS and between the MDS and the client. And this would be more of a build one. It would, like, you would do a lot of stuff with the CephFS code, but it would be mostly about like the compile time. Trying to split that up into an internal MDS types that are only used by the MDS and that only need to link with it, and into types that are shared with the client. And that would be good because it would make builds go faster in a lot of cases, and it would make linking and packaging and various other things that we run into across the years a lot simpler. Okay. Thanks, guys.
Awesome. Thanks, Greg.
All right, and we need to do our stop and start.